Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. Okay, today we're going to continue with our Newton interpolation. We have one more Newton that we need to discuss. Previously, we have seen into the Newton forward, we have seen the Newton backward, and the two Lagrange and least square. But we have one more here that we call as Newton divided difference. As you recall previously, for Newton backward and Newton forward, it is suitable for only uniform data, right? We have discussed extensively about how to use, what is a suitable way to use the Newton forward and Newton backward. But for Newton divided difference, it is suitable for non-uniform data. So it's quite different from forward and backwards, right? So if you see where, if the h you want to find, right, it is non-uniform, so you can use the Newton divided difference. Right, that's the main differences between a Newton divided with Newton forward and Newton backward. Right, so actually the zero will be divided difference of the function f with respect to the x. Okay, we will see later. Of course, they will have the table, so we will look into the table. And for the first divided difference of f with respect to x and x plus 1, so this one is actually the equation that we need to do in order for us to find the first difference, the second difference, the third difference, and so on. Then we will have the table. Okay, quite similar to Newton forward and backward, where we need to have the table. Okay, as I mentioned before, this is the equation for the second divided difference. You can see here, it will continue until the nth, depending on how many that we have. Alright, if you have until 4 or 5, we need to find the divided difference for each column. Right? So, if you can see here, it's quite similar, the table from what the Newton forward and Newton backward. Right? This is the x, and we have 3 columns, the same as before. We have 3 columns given to us, the k, the x, and the fx, right, from the question. So based from the question, usually in a row, so you make it into a column, right, similar to the forward and backward. And then this is the things that we need to find, right? We need to find the table for the first one, table for the second, the column for the first one, the column for the second one, and so on. So this, if you want to find this, right, this will be the equation, right? So actually, fx1, this one, minus this, divided by this one, minus this. Okay, then you will get the value here. So actually, the format of the table, it will be like a Newton forward, right, going upwards, like this, going upwards. Okay, so to find this one, fx2, so fx2 minus fx1, x2 minus x1, then you will get this value, and so on, this one and this one until n, right? For this one here is what? Here, the answer for this minus the answer for this, divided by x2, which is this, minus x0. So for the second column here, this one, second divided difference, we start at x2 over here. This one, xn, it will be x3. Let's say, they say this is x3, right? So we start at x3 minus x0. So basically, the more, let's say this one, the more column you have, it will start at that x minus x0. Okay, this one x1, because this is the first, right? x1 minus x0. This one second column, so x2 minus x0. x3 will be x3 minus x0, x4 minus x0, and so on. Okay, that's the difference of calculating the Newton divided difference, right? Right, after you have the table, you need to use the interpolation. Okay, the Newton divided difference interpolation. It's quite similar to the forward and backward. After you get the table, there you need to put all of your findings into this interpolation polynomial. Alright, as usual, we'll go straight to the example. So here they ask for the construction of Newton divided difference table based on the following data. Right. So if you see the data here, the H is not uniform, right? So this is 0.2. This is 0.2. This is 0.5, right? So this one is different as well. This one is different as well. So basically, you cannot use the Newton forward and Newton backward for this one. So if the question asks for Newton to do this, so you can use the Newton divided difference. Okay. So the approximation value is y 1.3. So y is over here, right? They want to find it over here. So it is suitable to use, right? Because if you see the table for Newton divided difference is towards the forward, right? It's towards the top. So basically the table will be like this. If you see the table before, it will be like this, right? Going down. So there will be many more points over here, right? So if the point 1.3 is suitable for Newton forward, Newton divided difference for this time. Later after this, we will see example where if the point is at the back, right? So what can we do if we need to use the Newton divided difference? Okay, for now, it's okay because the value is on the front. 1.3 is over here. So basically we can just do the table. Okay, these are the table that have been produced by the solution. All right, we can see we have this is from the question. This from our question. We can simply directly make it to the table, just the same as our Newton forward and backward. But this is the first column that we need to do, second column, third column, fourth. And it depends. If you have more, it will be more columns depending on the question, depending on the table that you have, right? So how do we get this number? Okay, so here if you can see, make some calculations, right? If you want to find, let's say, okay, these are the line that we have from the table, okay, K, X, and Fx. This is from the table of questions. Okay, you need to develop this one. This is the first, this second column, third, and the fourth column. All right. So to find this is what you need to do the calculation, where 0.3846 minus 0.5 divided by x1, which is 1.6 minus 1.0. Then you will get this value, right? The next value, okay, 0.2857 minus 0.3846 divided by 2.5 minus 1.6, right? And so on. And then you will get your first column. What about the second column here? All right. This one, we use what we found at the first column here, right? Negative 1.099, this one, minus negative 0.923, this one, and divided by, now it's not x1, it will be, because this is column 2, so we start with column 2, 2.5 minus 1.0, all right? So you will get 0.0549, this value. Okay, how to get this value? Negative 0.0714 minus negative 0.1099 divided by 3.0 minus 1.6. Okay, so you get this value. Right, so this is the calculation that you can see. This is for the 0.0549, this is for 0.0275. For the second row here, for the third row here, this one 0.0170. So you can see this calculation whereby you have this minus this divided by 3.2 minus 2.5. Right? Okay. Let's look at this one, number third here. Third column you need to find. So you use what you find as usual in your second column. So 0.0549 and 0.0275. So this one minus 0.0549 divided by, now because it's 3, right? So Number 3, 3.0 minus 1.0. Okay, and then you get the value here. And this is the calculation you can refer to. Next one, how to find this number. So this minus this divided by 3.2 minus 1.6. Right, so you will get this value, 0.0066. The last one, number 4 here. So this one, 0.0066 minus negative 0.0137 divided by 3.2 minus 1.0. So as we go along the column here, the value of the x increasing. Okay, for column 1 we start here, 2 we start here, 3 we start here, and 4 we start here, minus 1.0 at the starting. Okay, so that's the equation that you need to understand on how to calculate the Newton divided difference here, right? And if you can see why it is suitable to the to the front value here, because we have so many points that we can put into the Newton divided difference. Right, that's why it is suitable for the front number. We want to find 1.3, right? So 1.3 is over here. So we have a lot of points that we can use. All right. Right, after you have all the calculations, okay, this is the calculation for, because we want to find a 1.3, right? So this is actually similar to the table before. You have this the first calculation for the first column, the first calculation for the second column. I think this is 0549, right? 549. Okay, 0.0. Okay, this is the first column of the third column, the first calculation of the third column, and the first calculation of the fourth column. We can refer to the table, right? This one we have it calculated in the table before. The last step after we have done the table, right? We have done the table, and then we have chose the points that we need to put into the interpolation polynomial here, which is point at 1.0, because I have the most point. Remember the table before, so we have 1.0, 1.6. This one you have the most, right, point. We have until 4. I think this one is only 3. You can refer to the table. So 1.3 is in the middle. So we choose this one, right, as our polynomial expression. So we have all the value. Just put into the polynomial expression. This will be the last one. P4 1.3. So this will be the value. First one 0.5 given, I think given by the questions. Okay, this is the calculation for the first column, first row, and then calculation for second column, first row, and then third column, first row, and the last one we have fourth column, first row. Okay, this is basically on the most point that we have based from the table we have done before. Right, so we do the calculation, so you get your value here at the last, 0.4353. Right, that is the example of question that is straightforward. Means that they ask to find the point that is towards the beginning of the table. Okay, towards the beginning of the table, where it's easier for us to find the most point, right? Because at the start of the table. What about if they ask you the point that is not located at the beginning of the table, right? Means that it's different from our previous example. Previous example, straight away, 1.0 is the first number, right? The first one, and then the next one is 1.6. So they ask for 1.3. So basically, you can just do the table for Newton divided difference. If they ask towards the ends or in the middle or something, right? You need to order the data. Okay, you need to order the data, right? So if you see the statement here, Newton divided difference formula can be used to determine approximation of the point lies near the beginning of the table, where x0, x1, and you need to find this one before. So previous example, this is 1.0, right? This is 1.6, and you want to ask to find 1.3. So basically we can just do the table directly. Do the Newton divided difference table, and then find the most value that we can put into the interpolation, then use the interpolation to find the answer, right? But if it is not like this, if the data is not like this, that you need to find not 0.3, you need to find other numbers, right, that located towards the end of the table. You need to reorder the data. How to reorder it? So we need to see the next example. Right. If you look at this question, I think the same table, right? Same table as before, but now they want to ask you to find at y 2.8. So 2.8 is over here. Alright, is over here. So you can see the h is not the same. It's not uniform here. But I think this is the same question as before. So we need to use the Newton divided difference for this problem. Alright. Alright, if you have this type of questions, first thing you need to do is not to develop the table. First thing you need to do, you need to reorder first. Right, so you need to reassign back the table. Okay, so this here, x 2.5, here, right, this one x 2.5, and 3 here, 3.0. Now, these two will become your x0 and x1. Why? Because we want to find 2.8 over here, right? So this will be your new x0, this will be your x1. Okay? Alright, so basically, if you want to find something in between, the first one will be the 0, and this one will be the 1. Right? Now, how can we find the next number in our reordering? Okay? So we need to now reorder the remaining points based on the proximity to 2.8. Right? So we have 1.0, 1.6, and 3.2. Now you need to see which one is the closest to 2.8. If you do the math, right, 3.2, 2.8, okay, that will be the closest, right, after 3.0. So because this one is 0 and 1, so we need to find number 2. Right, so find the closest one. Of course, the closest will be 2.5 and 3 because it is in the middle here. The next one, the closest one is 3.2. Right, so 3.2 will be our x2. After 3.2, see whether 1.0 or 1.6 is the nearest one. The next closest one is actually 1.6. So this one will be x3. And the last one on the table will be 1.0 because it's the farthest from the 2.8 that we want to find over here. Right? So this is the first thing that you need to do. If the x that they want to find is not at the start of the table, so you need to reorder things. Okay? Alright, this is the answer for the solution before. This is the table. Okay, this table, if you can see, we start with x0, which is 2.5 is x0, x1 is 3.0. Why? Again, because we want to find the 2.8, which is in between 2.5 and 3. So this one will be 0, this one will be 1. And the next closest one is 3.2. And the next closest one to 2.8 is 1.6. The next closest one to 2.8 is 1.0. Okay, so this is how the table should be. Okay, the order it. So basically, you need to order depending on what's the new x0, the new x1, the new x2, the new x3, and the new x4. Alright, so basically it's not the same anymore with the original table because we have reordered it in order for us to have more points for our Newton divided difference. Okay, so we want to find 2.8, so 2.5 will be the zeros and so on. Ones, the next smallest one, the nearest one is 3.2 and so on. Okay, the calculation to get these all are similar to the table before. Okay, the only difference here is we reorder first. After we reorder, then the calculation is the same. Okay, let's look at the calculation. Right, now after we have reorder, so this is the new table that have been reordered, right? So this is given from the table. On the left hand side here is given by the table. So this is what you need to find, which is, this is the first one, second column, third column, and fourth column, right? Okay, to find this, 0.25 minus 0.257 divided by 3.0 minus 2.5, right? Then you get this. To find this, 0.2381 minus 0.25 divided by 3.2 minus 3.0. So you get this, and so on. I think you get the idea already, right? Or you can refer the calculation down here for the first column. For the second column, this is the calculation, right? So basically, to find 0.0170, negative 0.595 minus negative 0.0714 divided by 3.2 minus 2.5. Remember, this is the second column. So basically, we start at 2. Okay. The third column later, if you look here, this is the calculation for the second column. You can find here. Calculation for the third column here. So basically, to find 0.0066, so 0.0229 minus 0.0170. Okay, so this 3, right? So we start here. 1.6 divided by 1.6 minus 2.5. Right? So you get the answer here. And so on. This one, 0.0458 minus 0.229 divided by 1.0 minus 3.0. Okay, so we get this one. This is the answer. So actually this will be 0.015. Right. So this one, the last one here, this minus this divided by 1.0 minus 2.5. So you get this one, 0.33. 0.0033. Okay, you can refer to the calculation here if you are quite confused on how to get this value. And it must be populated in this type of way, upwards. Okay, so will we use this value here, this calculation value 0.28, this one, because the most point, right, that they have is the value in our interpolation after this. Okay, the last step, the same as before. The last step is we put into the polynomial. Okay, we have do the reordering, and we have do the table, and we have selected the value that we have in the table, right? So this will be it. So we have 1 point, 0.2857, second point from the second column, this one and this one. So we have 1, 2, 3, 4, sorry, this one, 1, 2, 3, 4, 5, right? 5 points that we can use into our polynomial based from the table before, right? So you do the calculation and then you get your answer here for the P4 2.8. Right, so that's it, I think, for Newton divided difference. Right, so we can use Newton divided difference for the non-uniform data. If the question wants you to do Newton, but the H is not uniform, you can use the Newton divided. If the H is uniform, you can use either forward and backward. And depending where the point that they want to find, if the forward, I think I mentioned before, in the forward is more towards the front, right? The front here. The front end of the table where you can find the Newton forward, Newton backward towards the end, right? But for Newton divided difference here, it depends. If the point, for example, this one is 2.2, right? 2.2 is over here. So basically, you don't need to do reordering. You just do the table directly. Okay? Do the table directly. Make these 3 row into column and find the first column for the fx, f1x, right? And f2x and f3x using the formula, right? The equation. But if here f7.0, which is here, So you need to do reordering for Newton divided difference, right? So you need to do reordering. So basically this will be the x0 and this will be your x1, right? And then find 7.0, right? So between 2.0, 3.0 and 12.0, which one is the closest to 7.0? Then it will be the x2, and then x3, and then x4. The last one will be the farthest one from 7.0. Then you have your reordering complete. Then you can do the table. Okay, so for Newton divided difference, you can do at the start and at the end. If the point at the start, directly here, for example, here's point over here, so directly use the table. If the point at the different place on the table, you need to do reordering. Okay, please do this exercise as well.